Hi everyone, we're going to sketch the curve and find the area that it encloses. R equals 4 plus 3 sine of theta. This is a limicon without an inner loop because 4 is greater than our 3 here. And I'm assuming that since we're having to do the area here that you're more familiar with polar curves. It says just to sketch it. We know it's a limicon. So I just went from 0 to 2 pi, and we're going to add some values for that. So basically at 0, we're going to get 4. At pi divided by 2, we're going to get 7, because sine of pi divided by 2 is 1. So at pi, we're back to 4. At 3 pi divided by 2, we're at 1. And at 2 pi, we're back to 4. So basically, we're going out 4, 1, 2, 3, 4, 1, 2, 3, 4. And on pi divided by 2, we're at, where's that? 7, yeah. 1, 2, 3, 4, 5, 6, 7. All right. At 3 pi divided by 2, we're at 1. So basically, it's going to, we're just sketching it. It's going, and I can't sketch very well on this. So basically, you know it's a limicon, so it kind of swings out like that. Kind of looks like an apple. So you swing around, and there's the sketch. And it looks more like a pear, I see. All right. So anyway, the goal here is for you to determine when we take the, find the area, what are going to be our, where are we going to look for the integration. Basically, we're wanting the area of this enclosed area, and we had to use everything from 0 to 2 pi. So when we integrate, we're going to go from 0 to 2 pi. And we do this always with limicons. So once you get used to that, you don't really have to keep graphing it to figure it out, because the limicon usually always swings out to all 4 quadrants. All right, so let's go ahead and get the area that it encloses. So we're going to use this formula, and we know now that we're going from 0 to 2 pi. We take 1/2 of our r squared d theta using this formula, and this is 4 plus 3 sine of theta. All right, so let's go ahead and simplify this. We're going to get, I'm going to pull out the 1/2 and then expand this, and this is going to give me 16 plus 24 theta, or 24 sine of theta, plus 9 sine squared of theta, d theta. All right, now from here what I'm going to do is go ahead and simplify this sine squared of theta to make it easier to integrate. So I'm going to write this as 1/2 times the integral of 0 to 2 pi, and we have 16 plus 24 sine of theta plus, now this is going to be 9 times 1/2, and using your identities for sine squared, this is 1 minus cosine of 2 theta. And this is d theta. So on the next slide, what I'm going to do is this is going to end up being 9/2 plus 16. And then you have to also multiply it by this. So let me do that next. So we're going to have 1/2 the integral from 0 to 2 pi. And now when you add the 16 plus 9/2, that's going to give you 41 divided by 2. Just copy down your 24 sine of theta, and then we have to multiply the 9/2 also by our cosine of 2 theta. Now we can integrate. So this is going to give me 1/2, and then we're going to have 41 divided by 2 theta minus, change this to cosine, 24 cosine of theta, and change your sign. And this is going to be minus 1/2 times 9/2 sine of 2 theta. And we're evaluating this from 0 to 2 pi. Now I'm going to go ahead and change this to 9/4. So I don't have to make a new line. So that's 9/4. All right. So when you evaluate this, this is going to give you 1/2 times 41 pi, because the 2's will cancel out here, minus 24, because cosine of 2 pi is 1. All right. And then this is going to be 0. And then for 0, you're just going to get minus. This is going to be 0. This is going to be minus 24. All right. And this is going to be 0. This is going to give you, this is going to be negative 24 plus 24. So this is going to 0 out, minus a negative 24. So that's going to be plus. So we're left with just this, which gives us 41 divided by 2 pi. And that's it. Thank you. Have a nice day. Bye-bye.